Hello everyone and welcome to this machine learning playlist. Today we are covering an important topic, so whether you're someone who is absolute beginner or you have some experience with machine learning, this playlist has been designed in such a way that it will be easy to follow for everyone. Also packed with lots of values and information, and it will be really helpful for you, especially if you're preparing for a machine learning based job role like data analyst or data scientist. So please subscribe to the channel and drop a like below to support our work. And without any further delay, let's get started with today's topic. Hello everyone and welcome back to this new lecture within this series of machine learning. This topic is going to be around a high level overview on ensemble learning. So we will just try to get an overall idea that what kind of techniques are there within ensemble learning and for what purpose they are being used. So it is going to be a quick lecture, but very important for those who do not have much clarity around this topic and also for those who are preparing for interviews. So ensemble learning models are considered as one of the best high performing model within machine learning. It is used to achieve low bias, low variance with our model, which in other words we can say it helps us to achieve a generalized model. In ensemble learning, we combine two or more models to build a more accurate model, and we will have further explanation around it. Next is boosting and bagging are two approaches used within ensemble learning. Let's first discuss about bagging technique. It is a method where we take a data set, then we train multiple base learners parallelly, and once the training is done, taking all the outputs from all the base learners, we come up with an output. If you remember from the previous lecture around random forest algorithm, we discussed the same thing exactly. So random forest is a bagging technique. If you can remember, we discussed the same thing around creating a bootstrap dataset by randomly selected records, and then we choose a subset of variables out of this bootstrap dataset for each and every base learner, or you can say each and every decision tree, in order to do the training. And then if we are solving a classification problem, we will consider the majority of the votes for the same class in order to do the output. Let's say if 3 out of 4 model is saying it is class 0, not class 1, and only one model is saying it is going to be class 1, not class 0, then our final output will be class 0, the class which is being voted by majority of the base learners or majority of the decision tree model. Similarly, if we are solving a problem on regression where we need to predict a continuous value, we will take the output from all of these base learners and then calculate the average value or the mean value in order to do the prediction for the regression problem. So this was about a bagging technique or the random forest technique. By the way, if you have missed the previous lecture on random forest algorithm, then please consider watching that first so that it can make more sense to you. So within bagging technique, models with low bias and high variance are used, like decision trees. This technique is also known as bootstrap plus aggregation because we are using a bootstrap dataset and then we are aggregating the results from all of the base learners or all of the parallelly trained decision trees in order to come up with the output. We reduce the variance by training multiple base learners parallelly. So ideally in a random forest algorithm, you are training around hundreds of decision trees, and this helps you to reduce the problem of variance or overfitting. The partition is random, that we have already understood going by the previous lecture, and the goal is to reduce the variance of the model. It uses a weighted or average function for the final output, exactly the same thing that we discussed earlier. If we are doing it for a classification problem, then majority of the votes will be considered in order to do the classification between multiple classes, or the average function will be applied for a regression problem where we are trying to predict a continuous value. Now let's talk about the boosting technique. In a boosting technique, we take the data set and then instead of training all the base learners parallelly, we train them sequentially. So first, this base learner will be trained, and then considering most of the misclassified data points by this base learner, or you can say the data points where the model could not perform well, mostly those records will be sent to the second model. So it will learn from the mistakes of the previous model. And then similar thing continues with the next models down the chain to the last model. So previously, the way we were training in a bagging technique, all the base learners were being trained parallelly, but that thing is not happening here. The training for all the base learners is happening sequentially, one at a time. Example of some boosting techniques would be ADA boost, gradient boosting, XG boost, etc. All of these topics or all of these boosting algorithms we are yet to cover within this playlist. So please consider pressing that bell icon along with the subscribe button so that you can get notified when I'm uploading those lectures. So within the boosting technique, models with high bias and low variance are being used, and those are called stumps, and we will explore this thing further in the upcoming lectures. Multiple weak base learners are trained sequentially to collectively become a strong model. So the idea of training all these base learners sequentially is to collectively make a strong model that can do the prediction for us. We reduce the variance by training multiple base learners sequentially. Misclassified data is given more importance. The way we discussed earlier, each and every base learner will learn from the misclassified data points by the previous base learner, and it aims for the increase of prediction accuracy. This uses the weighted majority vote function for final output, and we will simplify or explore this thing further in the upcoming lectures once we discuss the topics like XG boosting or gradient boosting, etc. So that was it for today's lecture. I hope that you found it useful. This was just to give you a high level overview around ensemble learning. So I hope that you found it useful. Thank you very much for your time.